Welcome back to Who Wants to Be a Mathematician. I'm your host, Mr. Hill. We're coming at you with some applications of solving triangles using trigonometric functions, the whole SOHCAHTOA. Huge, exciting stuff coming at you. So let's dive right in, shall we? So in this lesson, our objective is to solve word problems and triangles. And how we're going to do that is we're going to set up a picture, and then we're just going to figure out what trig we're going to use there. So step 1, draw the diagram. Label the known and unknown. Step 2, write an equation. Step 3, answer with units. Pretty straightforward. So the first problem states that the longest truck-mounted ladder used by Dallas Fire Department can be extended up to 108 feet. An expert of aerialness, that means when ladder's in the air, says the optimal operating angle is 60 degrees. So that's what we want. So let's assume that the ladder is mounted 8 feet off the ground. So we got a little fire truck here. We got a ladder coming off of the fire truck. And it's telling us that this distance here is 8 feet off the ground. So we want to figure out how far away from an 84-foot burning building is this truck. So let's draw our burning building. We got some colors going on. Burningness, get some reds in there. Pretty sure blues, like really hot flames, and then let's get some vibrant yellow. So we got this burning building, we got a fire truck, we got a ladder, and we want to figure out how far away is the truck from the burning building. So we want to find this distance. And what does it tell us? It tells us that the operating angle is 60 degrees, so we know this is 60 degrees. And the building is 84 feet high. So this whole distance is 84 feet. So if we pull our triangle out here, we have x, we have 60, and we want to find this distance. Well, this distance is only this part. We know this is 8 feet, this whole thing is 84 feet. So if we do some math, we just subtract off the 8, we get 76. So now we have an opposite side, we have an adjacent side, and we have an angle. And the way we know they relate is called tangent. So let's pull out our tangent of 60 degrees is equal to our opposite over our adjacent. And doing some algebra, multiply both sides by x. And then we're going to divide by tangent of 60. Forgot my calculator. Oh my gosh, hold on. How embarrassing, it was in the other room. Alright. So we got tangent of 60, or 76 divided by tangent of 60. 76 divided by tangent of 60. That's going to be 43.88. And what is all of this in? We need to have our units. We're in feet. So we need to add on the units. And there we go. It is 43.88 feet away from the building. Nice job, everyone. Give yourself a pat on the back for that one. So in another situation, the truck cannot achieve the optimal angle and need to fully extend the ladder to 108 feet. So if we redraw our building that's burning, we know that we have a truck over here, got some wheels. The ladder had to be extended fully. So this is 108 feet, had to be extended fully. The building is still 80, oh my gosh. Alright, let's just the building is still 84 feet tall, and the ladder is still 8 feet off the ground. So what are we trying to find? Find the angle between the ladder and the fire truck. So we want to find the angle between the ladder and the fire truck. So we're trying to find this good old pal here. So if we redraw our triangle, we have theta 108. We know this distance over here is still 76 because it's still 84 feet tall and the truck is still that. So if we have an opposite side, this is going to be our opposite side, and we have a hypotenuse. What relates those two? We know sine of theta is equal to opposite over hypotenuse. So we know sine of theta is equal to our 76 divided by our 108. So we come over to our nifty-difty calculators, and we do 76 divided by 108. We do 76 divided by 108, can't type. So we know sine of theta is equal to 0.704. Well, how do we get rid of this? Because we want theta, that's what we're trying to find. We're trying to find the angle. We want theta. Well, we take the inverse sine of both sides. So these two will cancel out, leaving theta, then we'll have sine inverse of 0.704. Plug that in a calculator, we're going to get a theta of 44.72. Now we're almost done, but what is theta? Theta is an angle. An angle have what type of measurements? Have degrees. So make sure you put degrees there. So 44 degrees and 72 points of a degree. Very good. So now we're going to switch it up a little bit. We're going to introduce this thing called angle of depression. So angle of depression is going to be the angle looking straight out that you look down at an object. So if you look down this blue squiggly arrow, it's the amount that you have looked down. So it's going to be that angle. So just keep that in mind as we move forward. So here we go. A person stands tall on a beautiful rocky, red rocky cliff. We know it is 20 meters tall. We know a person standing there. Let's have it be a lovely person with feet. We'll make it female, give her a dress like this. Oh, it's a he. Just kidding. Alright, we can't have he's being she's. That would just be barbaric. So he is looking down. So he's looking down off of the cliff at a car. There's a car down here. And we want to find what is the angle of depression. So we want to know how much he is looking down. So if we set up our triangle, we have the car over here. We have the man up here. We know this is 20 degrees. We have a right angle there. We know that this angle of depression is 35 degrees. I guess I was wrong. We want to find out how far the distance the car is away from the cliff. So how far is the car from the bottom of the cliff? Well, we almost have everything we need. But this degree out here doesn't really help us. So we need to figure out how to put it inside this triangle. And we notice if we look really carefully that these meet at 90 degrees. So we have 90 degrees making up 35 and something else. Well, what is that something else? We simply subtract it from 90. So 35 plus 55 is going to give us 90. So now we have our triangle. We have 20, we have 55, and we are trying to find that. Well, x is going to be our opposite side. This is our opposite, and this is going to be our adjacent. So opposite and adjacent is going to be tangent. So tangent of our angle is equal to our opposite over our adjacent. And this is simply 20 times tangent of 55 is equal to x. And if we plug that into our handy dandy calculator, tangent of 55, we're going to get out x is equal to 28.56. And what is it? Is it in meters, centimeters, miles? It is in meters. So that car is 28.56 meters away. Alright, let's finish up one more example. Find another person standing 40 meters away from the bottom of the cliff is looking up at the person. Find the angle of elevation. So we're going to have our lovely red gray rock cliff again. we're going to have our person standing up on top. And now we have another person down here looking up at them. And we know that they're 40 meters away from the cliff. We know the cliff is still 20 meters. And we want to find what angle is the person looking up at them. So if we draw our beautiful triangle, we have 20, 40, and we're looking for theta. So how do these relate? Well, we have this is going to be opposite. This is going to be adjacent. So we know that tangent of our theta is equal to opposite over adjacent. Or tangent of theta is equal to, what is our opposite? Our opposite is 20 over 40. So we want when tangent of theta is equal to 1/2. Well, to figure out what theta is, we have to take the inverse of both sides. These cancel out, so we're left with theta on the left side, and we have tangent inverse of 1/2. Well, what is tangent inverse of 1/2? Let's find out, shall we? To the calculators we go. Theta is equal to 2.6. Oh, just kidding. Just kidding. 26.57. And theta is an angle, so it's in degrees. So the angle of elevation is 26.57. Well, there we go. We got a couple examples under our belt. Next video, we're going to come at you. You're going to do some guided practice work, and we're going to finish up with a couple more examples. See you next time.